Saisha, any doubt in functions?
No, sir.
Yes or no? Doubt in function, yes or no? If there is doubt, let me know, I can repeat it. Aggregate functions. Okay. Yeah, if I ask you, everyone will be having doubts in all.
कर रहा है कब से चल रहे हो सर? सर पिछले कुछ दिनों से आवाजाही बढ़ गई है सर.
That's why I don't like other rooms. TV gives lot of troubles. OTT. What you did in last 2 days? So when there was a time to watch OTT, you slept. Not even studied, right? And you guys want placement as soon as possible. Who will give you? Sundays for those who are tired of working 1 week. Not for those who are who are tired of just sitting at home and coming and going on. That's a part of life, Yeah, Sunday is also part of life. It's a regular part of life for you. Look at me. Daily I conduct 3 hours class here, and I work in a company almost for 10 hours. Saturday, I work for 13 hours in a company. I came back home around 4:35. Then again, I came back yesterday to conduct mock interviews and project for SQL class in the morning 11. Then again, I went in the afternoon to the job. So there is no option for working hard. Efforts will not look whether you are senior or junior. I have seen many people, or my juniors are, sometimes I feel that they are more intellectual than me. My juniors, like for those who hiring interview was conducted by me, sometimes I feel that they are more intellectual than me. They are aware of many more technologies. So it's all about putting efforts. Don't say that I am junior, I am senior. These are the excuses. If you keep on doing this, or if you keep on giving excuses, then life is also give you excuses. Why you are not having job? Life will say, no, there are no opportunities in the market. Everything is crashing down. Dollar is raising, rupees falling, so we don't have job. Just keep on working. I have seen many people when I was in the Intelli part. I was teaching there. There were 2 to 3 students who were working as a watchman. And on duty, they were attending these classes, working as a watchman. Now, what excuse you are having? Your fathers are giving you money. They don't even have the money. They were earning by themselves. They were paying the fees, and they were also spending for their self. And also, they were sending some money to the home. So there are a lot of people there who are working very, very hard, and that's why for average person, getting place has become difficult. Like I told you in the resume making class, demand is less, supply is more. In that supply, 10% are very smart, sharp, and hardworking students. Those are getting placed. Now the ones who are average, the ones who are giving like excuses, Sunday it's Sunday, then for you will face a lot of troubles. Okay. We born just to work. That's what I feel. We didn't born to enjoy. We born to work. Okay, which functions you are having doubt? Aggregate functions. Aggregate functions very easy. Sum, minimum. These are the. Suppose if I want to get the maximum salary, then I will write this max function before this salary column. If I want to alias some, if I want to give that column name, then I can use it as a alias. Let me explain this aggregate functions once. Now we are having employee table, right? Do we have? Yes. So if I want to see the maximum salary, then I will simply write select max column salary, and I will execute from employee. Now, if I want to give the column name, then I will give alias as maximum salary. Now, if I executed this, then you can see the maximum salary from my salary column is 5,000. And as I'm giving maximum salary alias name to that column, so maximum salary is a column name here. Got it? Next, suppose if I want to see the maximum salary from India only, then I can filter it by using where address is equal to India. Select this and execute this. So maximum salary for India is $3,000. Now minimum salary, I will use minimum function. For average, I will use average. For sum, I will use sum. That's it. What is the difficulty in aggregate functions? There is no difficulty, right? Okay. So let's start with the new module. Actually, this is the module number 6, but I'm taking it at the module number 4 because I feel that you should learn indexing first, then you should understand normalization, and then we will go towards other functions like filter, group by, then having clause, ranking functions. Ranking functions have we learned? No, that's in the module 4. So we will learn in that module. Okay. Yeah. So let's start with this indexing. Case functions are remaining. Okay, we will take it. Is it not? I think that's not in the module 3, right? Or is it in the module 3? Where are the case functions? Okay, okay. If you want, I can take it, but let's see the case functions in the next class. Case functions are nothing but the conditions we will give. Like already, suppose we are having employee table. Okay, now let's see. Suppose I am having employee table. Do we have? Let me view, select star from employee. And I want to give a new column here as a grade column. Now to give a grade column, I need to pass some conditions, right? Salary grade column, suppose I am giving. Now there are salaries starting from 1,000 to 5,000. Now I want to give some grade to the salary, and it should be opposite to the each salary cell. Then I can use case function. So I will write select star. Select star means I am selecting all the columns. Then I will write here case. Then I will write here when. Case when. And in the when I will pass some condition. Like I will write suppose salary is greater than or salary is less than or equal to 1,000. Then grade should be suppose C. Then second condition when salary is less than or equal to 2,000, then grade should be, suppose I want to give the grade here B. Then third condition I'm passing here when salary is less than or equal to 3,000, then grade should be suppose B plus. Or suppose okay, let me write B plus. Okay, when salary is greater than or is equal to 4,000, then grade should be suppose A. And now all other cases, if the salary is greater than 4,000, then I will write else. I will write here grade as a A plus. Now from which table I'm giving it? From employee. Now here I need to give the column name here. So just a minute. So this grade column name I need to pass here as salary underscore grade. Salary underscore grades. Okay. Show here. And number 2. Which one? EMPL OYE. I'm being old now, so my fingers are not okay pointing. Can you see? So this is how we can give the case statement. In the case statements are like if else only. Instead of is, if, we will use when, and else we will use else only. Like there are some conditions I'm passing. So you can see this salary is equal to or less than 1,000. So it got grade as a C. This salary is equal to or less than 2,000. So got grade as a B. Now this salary is equal to or less than 3,000. Got grade as a B. Now this is the 5,000 salary, and we have told that if salary is out of these conditions, then it should be A plus. So here we got A plus salary. Got it? Any doubt in this? Okay, write this case function. So like this way, you can apply this case functions to any of the column, and you can get the case, get the new column with the grade or any parameter that you are passing. Now these case functions are getting stored somewhere in our database or not? Now, do you think that whatever we have executed this, is it getting stored in my database anywhere? Yes or no? Is it getting stored? No. This is the top of the table query. It's not getting stored. Just whenever we are executing, we can see this. That's it. It's not getting physically stored in our database. So you guys should understand what is getting stored and what is not getting stored. Okay. Is it done? Case function always should start with case and end. End as that particular column name that we want to give. Done? Okay, great. So let's start with the index now. So what is indexing? Everyone uses books, right? So in each book at the starting we are having index page. Do we have? Yeah. Why that index page is given? Easy to search or navigate, right? Suppose there are 12 chapters and if you want to read the chapter number 9, if suppose that book is not having index page, then you will, it will search all the book pages, right? If suppose that book is having index page, you will go on the index page, you will see, okay, chapter 9, page number 72. So will directly open the page number 72. If there is no index present, you will not understand how many chapters are there, from which page number to which page number, and it will take a lot of time for you to open that particular chapter. Even you will spend 1 minute, where if there is the index, you can spend only 2 to 3 seconds. Got it? So same goes here in the SQL. Same goes here in the SQL. Suppose I'm writing one query here. Select star from employee, where employee ID is equal to 6, for example. Okay. And if I execute my query here, then I got the record for where employee ID is equal to 6. Employee first name is Ravi, last name is Singh, salary 3,000 and address is India. Now, if I turn on my execution plan, okay, and if I executed this again, and now if I click on my execution plan, and if I hover my mouse here, then you can see here it is showing that storage, raw storage, actual number of rows read. How many rows it read? No, 8 rows it read. Look at the row number 1, 2, 3, 4, 5, 6 rows number. Actual number of rows read. How many rows it read? 8. And how many rows this employee table is having? Where is this select star? It went away. How many rows this? 8. That means here, if I'm trying to fetch the details from any table, and even if I'm giving the filtering condition, employee ID is equal to 6, and if I view my execution plan, and if I hover my mouse here, then you can see there are total 8 records, and it's scanning for all 8 records. And after scanning all 8 records, just below there is one row, actual number of rows for all execution. How many rows it executed? 1 row. Now we had to execute only 1 row, or I was searching for only 1 record, then it should have searched for only 1 record, right? But still it is searching for all the records, and then it is returning 1 record. Now this table is having very less values. This table is having, how many values it is having? Just 8 values. So the execution time is low. But imagine the table that is having lakhs of records and thousands of columns. Lakhs of rows and thousands of columns. Now there also, suppose if I want to fetch details for 1 record, it will scan all the records first. Now scanning all the records will take time. That means we are getting output in a less, like in a it is taking a lot of time to execute that query, because it is reading all the record first and then it is giving us the record that we are asking. So here we are wasting a lot of time. Are we wasting or not? It's like that. I have given you the book. In that book, there are total 15 chapters. And I ask you to open chapter number 13. Now you are not sure where is the chapter number 13. So you will be flipping all the pages from that book. It will take a lot of time. And then when you will get the chapter number 9, then you will open the chapter number 9. It is a lot of time consuming process. And to avoid that, we are going to learn this index now. To avoid that, we are going to learn this indexing. So in SQL Server, when we are not giving indexing, when we are filtering records by normal way, then it is scanning all the records and then it is giving us the record that we are asking for. But if we give the index, then what will it do? It will not scan all the records. It will directly jump on the employee ID is equal to 8. so that it will scan only one record and it will return only one record. So the execution time we are reducing here. Got it? Yeah. So that's why indexing is important. So in the index structure, let's understand how the index structure works inside the SQL server. Indexes are basically created on the tables columns. Means where we are going to create the index, we are going to create index on the columns from table. Columns from table. The data using the column on which the index is created. Now suppose if I am creating index on employee ID column from this employee table, then what will it do? It will fetch this using employee ID column. And generally we will give index, like we will make index column to that column which is having primary key. We will prefer to give the index to the primary key column because primary key column is a unique column. Primary key column holds unique values. Means suppose if you are looking for a where employee ID is equal to 6, as it is a unique value and not null value, it will directly fetch that employee ID is equal to 6. Suppose if I made employee first name as an index column, then in employee first name we may be having 100 of records by first name, the same first name. Now suppose Instagram, you are working in an Instagram company or the Meta company as a database administrator or database engineer there. Now there are almost thousands of people are having name like Venkat. Now if you are trying to fetch where employee or where Instagram username Venkat, you will get 100 records. Are you going to get the unique records? No. So we will always prefer to give index column to the primary key column. Got it? Yeah. Next, this index structure, indexes are basically B tree. B tree means binary tree. Binary means 2. Okay. Structure which helps us in flattening our tables and hence providing easy access to the database. So I will make you understand what is binary tree. Okay. So suppose I am having employee IDs from 1 to 20. Okay. B tree means binary tree. It will first divided this 1 to 20 into the 2 segments. First segment is a 1 to 10. Second segment is a 11 to 20. Now again, this 1 to 10 will be divided into 2 different segments, 1 to 5 and 6 to 10. And this 11 to 20 will be divided into 11 to 15 and 16 to 20. Now this 1 to 5 will again divided into the 2. 3 to 4. This 6 to 10 is like 11 to 12 and 13 to 15 and 16 to 20, 16 to 17 and 18 to 20. Now these are called as nodes. These are called as nodes, and this is the binary tree structure. Now this structure is not visible to us. SQL server compute like this. What will you do if suppose I am making employee ID column as indexed column, then how many employee IDs are there? It will look for first. Suppose there are 20 employee IDs. So 1 to 20. So it will first bifurcate them in 1 to 10 and 11 to 20. Then 1 to 10 will be further bifurcated like 1 to 5 and 6 to 10. Then 1 to 5 will be further bifurcated like 1 to 2 and 3 to 4. Now suppose here I am seeking for details where employee ID is equal to 2. So it will directly jump on this where employee ID is equal to 2. So how many rows it will scan? Only one record it will scan and only one record it will return. It will not scan all these 1 to 20 rows. No, it will simply jump on this node 2 and it will execute that. So 19 records it is not scanning. So that time, it is being more faster, right? Because we are utilizing that time. We are not wasting our time on scanning all the rows or all the records. So that's how the indexing work in the SQL Server background. Any doubt in this? No doubt? Okay. So these are called as, this is a binary tree structure, and these are called as nodes, or you can say leaves. Nodes or leaves. Okay. So In indexing, we are having two types of index. The first type is a clustered index, and second type is a non-cluster index. First type is a cluster index, second type is a non-cluster index. So this is the structure for the cluster index. This is the structure for the cluster index. Suppose if I am creating this employee ID as a cluster index, and suppose if I am looking for a record where employee ID 2, then it will directly jump on this node or this leaf and it will give me the record. Okay. Non-cluster index, it will not directly jump. It will just address pointer. Address pointer means it will just tell that, okay, this is present there. Getting my point? No, I will tell you. Suppose if you want to open chapter number 7 in your book, for example, and if you are giving cluster index there, it will directly open that chapter number 7 on the book and it will give it to you. You don't even have to go and fetch page number 72. It will open the page number 72 and it will give it to you. Whereas non-cluster index will just address that this chapter number 7 is on the page number 72. You have to go and you have to open that one. Got it? This is the difference between cluster index and non-cluster index. Still, I will read once, and if suppose if I'm missing any point, I will make you understand. So cluster index, the complete data row is actually stored in a leaf node of the index. That means I told you, suppose if I'm looking for the employee ID is equal to 6, then complete data for that employee ID 6 will be stored in this leaf node. Okay. Next, the indexed column is either arranged in ascending or descending order. The data is physically sorted in ascending or descending in data file itself. You can have only one cluster index per table. You cannot have more than one cluster index per table. Only one cluster index per table. Okay, and that's why we are referring or choosing to apply this cluster index on which column? Primary column. Okay. You can include multiple columns in the cluster index. It's not always recommended to use the multiple columns. Means it's not like that. We cannot apply this cluster index on multiple columns. We can, but it's not recommended. It will create confusion in the SQL Server background. Got it? Whether to look for or whether to look for this. Got it? So that's why it is advised to have only one cluster index per table for the smooth search. And if you want to give cluster index on more than one column, you can do it, but it will make the process more complicated. You guys will get confused. Okay, so that's why it is advised to have how many cluster index per table? One. Okay. Table with cluster index referred to as a cluster table. The table that is having cluster index will be referred as a cluster table. Second, entire data row. That means in the cluster index, if you see here, 6 to 7 is given, right? So this 6 is storing all that record. Complete row it is storing record for that complete row. The 7 is storing record for that complete 7. But in the non-cluster index, it will not store the entire data row. It will not store the entire data row. Instead, it stores a pointer or memory address to the row in the memory. It will not store the record, but it will store the pointer, and that pointer will locate towards the record. Got it? Now suppose you came to this class for a very first time. Okay, you met at the management and they told you that, okay, go and sit in the projector classroom. Okay. Now suppose it is a cluster index, he will take you to the projector classroom. Okay, and in the non-cluster index, he will just point at you, okay, there is a projector classroom, go and sit. So that is the difference between cluster index and non-cluster index. So non-cluster index column data is stored, but on the fly, that I told you, you can have more than one non-cluster index on a table. SQL Server 2005 was supporting 249 non-cluster index. SQL Server 2008 supports 999, and now the SQL 2020 that we are using, it supports more than 1,500 non-cluster index on one table. But maximum times, 99% of times we will be using cluster index only, not the non-cluster index. Which index we will be using? Cluster index. Okay. So shall we start with this clustered index? Indexes are called as necessary evil. Necessary evil means it can make process smooth, or if you are applying this index, clustered index on more than one column, it will make your process complicated. So that's why before making any cluster index, you should understand that how many columns I am using this cluster index on. We should use on how many columns? Only one column. Can we use on more than one column? Yes, we can. But we are a good guys, right? So we will use on only one column. Okay. Let me share one table syntax to you. Write that query to create the table. I will share it on the group. Online students, I just shared one syntax to create a table. Please copy that syntax and paste it in the SQL Server Management Studio. For offline students, I am sending it on a group WhatsApp. So what am I doing here actually? I'm creating a new table called as IndexTest. I'm creating a new table called as IndexTest. And in this new table, I'm giving first column name as a ID, data type, integer, and constant I'm passing here, primary key. Second column I'm creating as a name, data type I'm giving VARCHAR, and character length as a 50, and I'm closing this. Okay. Then what I want to do here, in the ID column, I want to insert data for 10,000 employees or 10,000 IDs. Now, if I started manually inserting, select one, name Venkat 1, select 2, name Venkat 2, then union all, select 3, Venkat 3, union all, select 4, Venkat 4, union all, to write 10,000 records, it will take almost 2 hours. Okay. So what I did here, I used here while statement. Okay. So first I declared this @i, and this @i is nothing but the integer data type, and I'm starting with this one. Okay. So declared value I is having integer data type and first value as a 1. Then I am here defining while loop. In the while loop, I am passing here condition declared value I should be less than or is equal to 10,000. Then I am beginning my code. In the begin and end, I will pass my logic here. So insert into, in which table I want to insert these values? In the index table that I recently created. Insert into index. First column is ID. Second column is a name. And by using this values method, I am first giving my declared value I. Now what is the declared value I? It is having 1. Declared value I integer is equal to 1. So it will take 1, comma, then I'm passing in the name column. Comma means it is jumping on the second column here. Second, in the name column, I'm passing my name Venkat, plus I am casting @I as VARCHAR and given character length as a 5. Now cast I, what will it do? It will take the value of I, but where it will take? After this Venkat. Venkat plus means it will concatenate. Have we learned these cast functions or not? Substring, cast, concatenate, we have learned, right? Yeah. So in the name, I'm passing my name here, Venkat. Let me give this capital V. Venkat plus, and I'm casting @I, means whatever the value I'm passing here, it will become after my Venkat. Like suppose here it is 1, so it will take in the name column Venkat 1. Okay, as variable character and data type I'm giving here, sorry, character length I'm giving here 5, and I'm closing this, and I'm setting here declared I is equal to declared I plus 1. That means I'm giving one step. So first it will execute this. It will take ID as a 1, name as a Venkat 1. Then I have set declared I is equal to I plus 1. So second record will be like 2 plus Venkat 2. Third record will be like 3 plus Venkat 3. Fourth record will be like 4 plus Venkat 4. And it will go till this while condition gets break. So it will print 10,000 records, and when this I is equal to like while @I will become 10,000, it will break the statement. Got it? And this logic I'm passing here, and I'm executing these values. Okay. Now if I want to view my index table, select star from, the laptop is running slow, index test. For you guys, it may be executing. I don't know, something happened to my SQL server, and either my laptop became slow, that's why it's not executing it. Can you see? Huh? It's executing for you? Okay, great. For me, it's not executing. It's still showing the executing query for me. I don't know. Okay, declare it. I think some dirty data is there in my system. That's why it is still executing. Can you see? For me, it's showing executing query. So when it shows, that I'm not getting any output here. Select star from. When I type from, it's still typing slow. It's going. Okay. So when your system will, server will go down when there is some dirty data present. So in my system, there is some dirty data present. That's why it is still executing here. I'm not able to get the output. Now, what is dirty data? Dirty data means when I'm passing some logic here, instead of selecting all and executing, first I just executed from declare to end. I had to execute from this end till create table together. Got it? So when I do this, when I try to do some transaction here, and in that transaction, if I'm not properly selecting everything, then it will give us the dirty read. and that dirty data will not let us execute the query. Now for that also we are having separate model number 5. In that model number 5 we will be learning what to do when we are getting this dirty data, how to roll back the operation or how to commit the operation so that we can come out of that dirty read. Okay, so let me see, let me drop this table index test, but still it is taking me time. So whenever you say such things happens by some database administrator. Okay, now if you see my server is down, is it showing to me any database here? No. Is it showing to my database name here? No. Is it showing to my execute query here? No. And if I see here, if I suppose hide it, it will take a lot of time to get perform the operations, and in my system it will be showing like executing query only. So this is called as server is running slow, server is down. And why it goes down? Because there is some dirty data present. And dirty data, who gives the dirty data? Customer? No, the database administrator. Okay, and because of that many people loses jobs, because suppose this is my mistake, right? And if people are not able to recover from this, then that for particular time being it will not give data to anybody. Like WhatsApp went down. Now WhatsApp is a very big software, right? So people, it will affect everyone on the earth if WhatsApp went down for half an hour. And how it went down? Because of some database administrator mistake. So being a database administrator is also very, the job needs to be done very carefully, else you can get fired. So now what I need to do, I need to close my SQL server and I need to restart it again. Let me copy this. So always be careful when you are declaring values and when we are passing any logic in this while and begin statement. Okay. So let me open it again. Okay, index test is already present. Let me just view my table here. Okay, so this is my index test table, so which is having IDs from 1 to how many? 10,000. If I scroll it down, The last record is for the 10,000. Have I given any wrong condition here? Again, dirty read. You guys are also getting the dirty read or not? No, why am I getting the? I need to see some problems are there in my SQL setting, because what I did, my laptop was becoming very slow, so I like removed a hard disk and inserted new SSD. So I installed this again, and while installation, I think I have made some changes there. So that's why it is giving me dirty read again and again. So executing, table in already present. How many records it has stored? For me, it has stored only. Yeah, now it stored 10,000 records. So now it will execute me where ID is equal to 10,000. Yeah, it got executed. Okay. So I want to create a clustered index. So what will I do here? Already I'm having this index test. So I will not insert this index test here. What will I do? I will create a new table called as IndexTest underscore CI. CI means cluster index. And what am I taking? I am taking all the values from my index test table. Index test table. So this is my index test table. Is it? Yeah. So what I did here, I took all the values from this index test table and I stored into the new table called as index test underscore cluster index. Why I stored? So that while creating cluster index, I should not lose the data from this index test. I use the same method that we used to create the table backup. So what we can say, I just created a new table called as index test underscore cluster index, and I took all the values from this index test table. That means I created a backup for this index test table. Got it? Now I think we should create this index test table tomorrow, cluster index test table tomorrow, and non-cluster index, and then we will see the difference between the execution time and how many rows it is scanning. Okay, so let's meet tomorrow. Till then, have a good day and keep on studying. Okay, any doubt is there, let me know. Okay. Many people are not getting chance to study. You guys are getting, feel fortunate. Even that is the motivation for me to come and work here, because I think that many people are not having work to do. If God is giving to me, I should, do the work. Now God is giving you the time, you the everything to study, so you guys should study. Okay. Yeah. So thank you so much for joining. Have a good day. We will meet tomorrow at 10 o'clock and we will see the indexing examples and the normalization. Okay. Yeah. Bye.